This chapter, first we will look at proof by contradiction in a different video. Each video is dedicated to one of these exercises, multiplying and dividing algebraic fractions. Then we'll look at adding and subtracting algebraic fractions, and most important part of this chapter is splitting algebraic fractions into partial fractions. I'll explain in more detail what's that, and then we look at partial fractions which need to have repeated factors in the denominator, and we'll have a look in depth of algebraic division. Okay, as always, I emphasize before we start every chapter that my students have a go at the prior knowledge tests at the beginning of the chapter. So please pause the video, answer these questions, and then after you've tried your best to answer all of them, you can play the video and see my answers. Okay, so factorizing the first uh, question, it's not that difficult. You're looking for two numbers that multiply to positive 5 and add up to minus 6. Of course, they have to be minus 5 and minus 1 inside the bracket. If you did have to solve it, you would set this bracket equal to 0 and you take it out of the bracket. But we have not been asked to solve these equations, we have been asked just to factorize it. So therefore I'm going to leave it as it is. This part B splits into two brackets. If you think carefully, this is difference of two squares. X square is a square number, or rather a square term, and 16 is a square, and we call this difference because of the minus sign. That means that it will split into x plus 4 and x minus 4. Next question is again the difference of two squares. We're going to take 3x plus 5 and 3x minus 5. If you're wondering where that 3x came from, it's simply square root of 9x squared. Okay, so this when we see an algebraic fraction, we can factorize top and bottom separately. So the top will multiply, will be factorizing into x plus 5, x minus 3 and x plus 3. Factorizing the denominator involves looking for factors of 18. So we treat this 18 as a product of the two numbers we're looking for, and 9 must be their sum. So you're going to write out all the factors of 18. 2 and 9 don't add up to 9. 3 times 6 does add up to 9. Therefore, we're going to take x plus 3 and x plus 6. And multiplying this bracket will give you what's on the left. Okay, so let's look at the part B here. To factorize the top of this fraction, what I'll suggest to my student, yes, you can use prior trial and error. In our case, we'll have simply the only multiple factors of 2 will be 2 and itself, so 2 and 1, so it has to be 2x and x. But in other cases, I'll show you another method for the denominator. Let's just take 2x and x here. We need to find factors of 12, but one of them will multiply by 2. Be careful, so that this plus 5 will come from the fact that one of the factors of 12 is multiplied by 2. So it could be 3 and negative 4, or 4 and negative 3, or it could be 2 and 6. Okay, so how can we know which one to take? What I would do is, first of all, in most cases, to make my guessing much easier, I multiply 2 by negative 12. Then I can write my answer as x squared plus 5x minus 24. I know this is not the original equation. Yes, I did change it, but I will change it back. I multiplied 12 by 2. I'm looking for factors of 24 that add up to 5, positive 5. I know plus 8 and minus 3 will multiply to 24 and add up to 5. So I will write them in a bracket as x plus 8 and x minus 3. But I'm not going to forget that I multiplied by 2 and I removed that 2 at the front. I multiplied the 12 by 2. Therefore, now this is the time that I'm going to divide by 2. I'm going to divide 8 by 2, and if I write 3 over 2, that's not going to simplify. So this 2 in the denominator, I'm simply going to put it in front of the x in the bracket. So my final answer will be x plus 4 inside the first bracket and 2x minus 3 inside the other bracket. So that leaves no chance for me to making any errors. I guarantee when you multiply these two brackets, you will end up with the original question. So this will be our numerator. I'm going to repeat the same trick for the denominator. If you'd like to pause the video and have a go, please do so. So I'm going to remove 6. I'm going to leave the middle term, the second term as it is. I'm going to write minus 18 later. Going to look for factors of 18 that add up to minus 7. It's going to be minus 9 and plus 2. So I'm going to write x minus 9 and x plus 2. And now I am going to remind myself that I multiplied the 3 by 6. So I'm going to try to divide by 6 both of these numbers that I found here. Now if they do simplify, I'm going to simplify them. This simplifies to 3 over 2, but I'm going to put the 2 in front of the x because I don't want a fraction inside the bracket, and 1 over 3 will simplify to 3x plus 1. I'm simply writing 1 over 3 with 3 in front of it. Now I guarantee you that if you multiply these two brackets, you will end up with this answer here. Okay, so putting the answers together, we had the numerator there, and we are going to put the denominator under it. So 2x minus 3. We'll see that this 2x minus 3 is exactly the same as the one above, so they cancel. And we also have 2x, 3x plus 1 in the denominator. Therefore, the simplified fraction will be x plus 4 and 3x plus 1. Okay, so I'm going to, if you like to write this out for yourself, please do so. I'm going to rub this up so that I'll have a space for part C. Let's deal with 2C here. We know that the numerator can be written as two factors. You will have x here and x here. Factors of negative 30 that add up to minus 1. Minus 1 because there is a minus sign in front of the x in the middle. Minus 6 and plus 5 seem to be the right choices here. Okay, the denominator is rather tricky because of the negative sign in front of x squared. We're going to factor out the minus sign and write the whole denominator completely different. I'm going to write minus 3x because I factorized the minus 1 out, and minus 18. Now I know that two numbers that need to be multiplied to negative 18 and add up to minus 3. I'm going to just put x and x there. So factors of 18, 2 and 9 are not going to help us. 1 and 18 aren't going to help us. 3 and 6. If I put the minus sign in front of the 6 and plus sign in front of the 3, that seems to do the trick. So, in our case, we factorize the minus sign out here. So we're going to put it in the denominator. X minus 6 goes there, and x plus 3 goes here. Now, this bracket cancels away with this bracket there. Make sure you put a light line through it so that what's visible, the numbers behind the line are visible. Final answer, when we do the cancellations, is a negative sign in front of x plus 5 over x plus 3. Now it doesn't matter whether that minus sign is in front of the numerator or denominator, as long as the fraction is negative. Okay, so part 3 here, or question 3. Let's read the question. It's asking us to figure out whether this expression is odd or even or either. We don't know what parity n and m are. All we know is that 8 is an even number because 8 is 2 times 4. Therefore, 8n is 2 lots of 4 4n. Now, if you take an even number and multiply it by an odd number, you end up with an even number. And if you take an even number and multiply that with another even number, you still end up with an even number. So in any case, no matter what parity n is, we end up with an even number. Now, let's say for part B, parity of n is odd, parity of m is odd as well. Two odd numbers subtracted from each other will give us an even number. Now, if we start then with an even number and take away an odd number, we end up with an odd number, or vice versa. If you start with an odd number, an even number, you end up with an even number. So, in this case, it could be either. The answer is either parity. 3. 3 is an odd number, and if you take an odd number and multiply it by an even number, you end up with an even number. What if we multiply 3, which is odd, and multiply it with another odd number? You end up with an odd number. So in this case, we end up with either. The final answer could be either odd or even. So we move on to part D. We don't know the parity of n, but we know that any number multiplied by even number will be ending up with an even number. Now, if you start with an even number and you subtract an odd number, 5 is odd, what do you get? Let's say we have 8, take away 5, we end up with the odd number. Start with any odd number, any even number, and take away an odd number, you end up with the odd number. In this case, we always end up with an odd number. Okay, so I hope you found this helpful. I'll see you in the next video.